Assalamualaikum, my name is Nur Saida Nafisa binti Azmi and my metric number is E24A3400. Today, we would like to present our project on the application of Geographic Information Systems or GIS in analyzing spatial patterns related to human activities and the environment. I will begin by introducing the GIS tool used in this project. We use QGIS as our main desktop GIS software. QGIS or Quantum Geographic Information System is a free and open source GIS that is widely used to create, manage, analyze, and visualize spatial data. It supports both vector and raster data format and provides various tools for spatial analysis, data editing, and map production, making it suitable for environmental and land use studies. Due to its accessibility and suitability for academic work, QGIS was selected as the main GIS tool for this project. In addition, WebGIS platform allows spatial data and maps to be accessed and shared online, making the information more interactive and accessible to stakeholders. QGIS support WebGIS integration through plugins such as QGIS to Web, which allows maps to be exported to platforms like Leaflet or OpenLayers. In this project, QGIS was used to prepare spatial data and publish interactive maps online to support environmental spatial visualization.
In this study, we focus on human activities such as urban expansion, agriculture, and aquaculture occurring near protected nature reserve. These activities can lead to habitat loss, environmental degradation, and conflicts between human development and conservation goals. Understanding the spatial distribution of population and human activities is essential to manage this pressure effectively. Analyzing this pattern helps support sustainable land use planning, conservation strategies, and informed decision-making by policymakers. The objective of this project are first to map human settlements and aquaculture sites located near protected area to visualize potential environmental risks, and second to identify areas where human activities may conflict with ecosystem conservation and biodiversity protection. Third, to analyze spatial pattern and trend to determine zone of high environmental pressure. Finally, we use GIS and WebGIS tools to visualize, communicate, and share these results interactively, supporting better decision-making and increasing public awareness.
For the technical demonstration, first administrative boundary data was obtained from GADM, and Pahang was selected as the area of interest. Next, population data was prepared by creating a new attribute field and inserting population values for Pahang. The population distribution was then visualized using choropleth mapping with gradated symbology to show variation in population density. After that, additional layers including leisure and nature reserve areas and aquaculture location were added and overlaid to examine their spatial relationship with population distribution. Finally, the map was published as an interactive web map using the QGIS to Web plugin, allowing the spatial data to be explored online.
So we're moving on to the next map, which is Perak. First, open a new empty project using the project template. Second, add a OpenStreetMap layer so the street map appears as a reference. Add the vector layer for administrative boundaries and protected area in the correct order, making sure they align properly on the base map. Next, open the attribute table for each layer and check the data to ensure everything is accurate before styling. After that, change the symbology of the layer, for example, to blue so that all features are clearly visible on the map. Use the Quick OSM and Quick Query plugin to add points of interest such as leisure area and filter the data following the state chosen, which in this case is Perak. Adjust the layer order and visibility so that all layers and points of interest are displayed clearly without overlapping important features. Finally, use the QGIS2 plugin to generate the final map showing all layers, styling and query features in a clear and presentable format.
My name is Mufika Adira binti Mama Amdan. My metric number is E24A3503. Now I will briefly explain the process of how this map was created. First, I add population data for Johor into the attribute tables. This population data set was linked to the spatial layers so that demographic information could be analyzed and visualized within the map. Next, I add aquaculture data and nature reserve data using the quick query function. This step allows me to extract specific geographic features differentially based on the selected categories. After that, additional spatial data were added using quick OSM. This function was used to retrieve supplementary geographic features from OpenStreetMap to support the analysis. Once all the dataset were successfully added and organized, I adjust the layers order and apply operate symbology to improve map readability and visual interpretation. Finally, the complete map was published as a web map, enabling the map to be accessed, shared, and viewed interactively for further analysis and presentation purpose. In my project for Selangor, I demonstrated my digital skill by first organizing population data in attribute table. I then apply symbology to color code the district so you can see easily where most people live. By using layer, I made sure the map was accurate to the real world. Finally, I published it as a map web with interactive pop-up to make the information easy for anyone to explore. In digital skill section, I'm showing my ability to handle the QGIS lifecycle. I started by managing complete spatial layers and ensuring data accuracy. Then, apply a professional symbology to make a data readable. Beyond just visual, I perform spatial analysis to extract real insight. Finally, I demonstrated how to publish this data into the interactive web interface, making the analysis accessible to anyone with a web browser. Every feature on the map is linked to an attribute table which functions like spreadsheet. I use this table to store descriptive information like name or categories and quantitative data like population or distance. This allows me to filter or query the data, show only specific features relevant to the problems. Analysis and web export. We perform spatial analysis such as buffering or clip to extract new instinct. To make this accessible, I expect the project as the interactive web map using tools like QGIS Web or ArcGIS Online. This enables features like pop-ups, allowing users to click a feature to see its attributes and layer toggles to explore the data dynamically.
My name is Farsha Afia Judin, metric number E24A3318, and I will briefly explain about my map. The first diagram shows human activity population in Gua Musang, Kelantan, and the second one is Kelantan map.
I use official population data from the Malaysia government in CSV format and import it into QGIS. The data was joined to the district boundaries shapefile using the district name, and the population value appear correctly in the attribute table, which show that the join worked. From the table, districts like Kota Kinabalu and Sadakan had higher population value, while Nabawan had much lower value. This matched the actual population pattern in Sabah. I then apply graduate symbology, where darker color represent higher population highlighted color represent lower population, and it's making the distribution easy to understand on the map. Because areas with higher population usually have more human disturbance, the population layer was used as a negative factor in the analysis. Finally, all the layers were combined to produce the final sustainability map, which clearly show areas with high, moderate, and low sustainability for wildlife.
Next, application to environmental or spatial problem. First, data integration and preparation. GIS software like ArcGIS was used to compile and overlay multiple spatial datasets, including first, current land use maps, which is built-up areas, forests, and water bodies. Second, environmentally sensitive areas, which is protected forest or reserve. And third, soil quality, elevation, and infrastructure layers relevant to aquaculture suitability. Next, multi-criteria evaluation (MCE). Researchers applied GIS-based multi-criteria evaluation to assess land site suitability for aquaculture by scoring spatial factors like soil quality, proximity to water, population centers, and sensitive ecosystem. Next, combining layers in GIS to produce a final suitability map showing areas from high to low aquaculture potential. Third, buffer and conflict analysis. GIS was used to create buffer zones around urban and environmentally sensitive features, such as buffering urban areas to minimize land use conflict. Second, buffering protected zones to safeguard forests or ecologically significant land. And third, identifying conflict hotspots where aquaculture should be avoided and opportunity areas where development is less damaging. And last but not least, outcome visualization. First, show suitability versus unsuitable zone for aquacultures. Second, highlight regions where population pressures and land use change are most intense. And third, demonstrate potential impacts on natural reserve if aquaculture expand unchecked.
For this slide, I will compare desktop GIS and web GIS from the perspective of usability and accessibility. Desktop GIS such as ARCGIS Pro and QGIS is more technical. The tools are powerful, so it is very good for mapping and spatial analysis. However, it is not very beginner friendly. The software takes time to learn, and users usually need some training first. Desktop GIS also depends on the computer. It works best on a device with strong processing power. If the computer is slow, the process becomes heavy. Access is limited to one device because the software has to be installed before use. WebGIS work differently. Platforms like ARCGIS Online, Mapbox, and Leaflet are simpler and easier to explore. Users can open them using a web browser, so the system can be accessed from many devices, including laptops and mobile phones. It is also suitable for sharing maps with other people. Users can view the same map online, which makes WebGIS more collaborative and interactive. Next, I will explain the comparison in terms of scalability and application. Desktop GIS is suitable for small or medium-sized datasets. It is often used for research work, data editing, or tasks that require high accuracy mapping. However, when the dataset becomes larger, the performance may slow down because everything depends on the local computer. Desktop GIS is also not the best choice for real-time or continually update data. WebGIS is more scalable. The data is stored in the cloud, so it can support many users at the same time. This makes it suitable for public dashboard, monitoring system, and environmental applications such as flood mapping or land use tracking. WebGIS is helpful when information needs to be updated and viewed quickly by different stakeholders. Overall, desktop GIS is stronger for technical and analytical words, while WebGIS is more practical for communication, sharing, and real-time visualization. In this slide, I will highlight the strengths and limitations of both platforms. Desktop GIS is very strong for spatial analysis, modeling, and geoprocessing. It is suitable for professional or research-based work that require detailed results. However, it is less convenient for sharing and the user needs technical skill and suitable hardware. WebGIS is strong for visualization, collaboration, and decision-making support. Maps are easier to share with user or organization. The limitation is that the analysis functions are more basic compared to desktop GIS and performance relies on internet connection and server stability. To conclude, both platforms complement each other. Desktop GIS is suitable for analysis while WebGIS is suitable for sharing results with wider audience. The most practical approach is a hybrid workflow where the analysis is done in desktop GIS and the final output is published using WebGIS.
In digital skills section, I'm showing my ability to handle the full GIS lifecycle. I started by managing complete spatial layers and ensuring data accuracy. Then, apply a professional symbology to make a data reliable. Beyond just visual, I perform spatial analysis to extract real insight. Finally, I demonstrated how to publish this data into the interactive web interface, making the analysis accessible to anyone with a web browser. Every feature on the map is linked to an attribute table which functions like spreadsheet. I use this table to store descriptive information like name or categories and quantitative data like population or distance. This allows me to filter or query the data, show only specific features relevant to the problems. Analysis and web export. We perform spatial analysis such as buffering or clip to extract new instinct. To make this accessible, I expect the project as the interactive web map using tools like QGIS Web or ArcGIS Online. This enables features like pop-ups, allowing users to click a feature to see its attributes and layer toggles to explore the data dynamically. We manage multiple data layers such as vector data, points, line, and polygon for discrete features like ads, and raster data, pixel grids for continuous data like evolution and satellite imagery. We organize this layer into the logical hierarchy so that the most important information is visible without hiding the background contents. We also ensure all layers work in the same coordinate reference system (CRS) so they align correctly on the Earth surface. For symbology and visual hierarchy, we apply professional symbology to transfer raw data into a clear story. For example, we use graduate color choropleth map to show intensity and establish a visual hierarchy by adjusting line weight and color so that primary data stand out from the base map.
QGIS helps us map the distribution of human settlements and aquaculture activities near protected area more clearly. The analysis shows that some human activities are located close to the nature reserve, which may create pressure on the surrounding environment. Desktop GIS was useful for data editing and spatial analysis, while WebGIS made the map easier to share and understand. Using both Desktop GIS and WebGIS together improve the overall workflow of the project.